Amazon eventually envisions quantum resources being available as a cloud service.
A company like AWS, which is its business is delivering compute power to customers at scale and taking that burden off of the customer in terms of the hardware. This is a great example why this fits with AWS model, because the quantum computer itself would be put inside of a data center, and then we would use similar elastic computing resources to provide that access to customers.
Think of this as a more kind of a new vertical within their cloud business. In the end, it will probably be solved and monetized through one of these big cloud platforms, and AWS has a great shot at being successful there.
There's also potential for quantum to contribute to the development of AI and vice versa.
As quantum computers become more capable, they'll generate data sets that we can use to train AI. But then if you could start to feed it data, I think in terms of development of quantum computers, I suspect that AI and machine learning will play an important role going forward.
Despite all of the progress, there is a lot of work to be done.
These are small scale systems that involve, maybe 10 to 100 physical quantum bits. Ultimately, we need to be able to control things at like 100,000 or maybe 1 million quantum bits. So imagine this thing scaled out by a factor of 10,000. In the future, the cost and the size is not really scalable the way it is right now. So we have to innovate on this size and the cost at the same time as we're improving the performance.
But quantum is a long-term bet, and it is unclear when the billions in R&D could eventually pay off.
There really have been very important milestones reached in the last little while, but we should also mention the challenges we face too. We're still pretty early on, and there's large error bars in where we'll end up in time and when we'll have a viable quantum computers.